Hello everyone, my name is Arun and welcome to my channel. This series is a series of tutorials on C programming, and in this tutorial we will be looking at the format specifiers for the float variable. Now, just like in the last time when we saw the format specifications for integers, float also provides a few format specifications, and we'll look at them in detail in this video. And fortunately, unlike the format specifications for integers wherein there are like plenty of them, the format specifications of float are little less in number but more than enough to meet our day-to-day needs. So let's look at them. Suppose if I have a float value f1, let's say a variable like f1, let's say like this one, like minus 95.56. Okay, you have various ways to print them out. So I'm just going to comment out all of these so that, and let's see, where is that format? Yeah, I'm going to comment out all of these, and I'm going to run this print statement alone to tell you what's happening. So if I have a float number like this, okay, and if I want to print it without any kind of specification or complication, I just want to print the number as it is without any setting, the free format, and the format specification is just %f, just that will do, just f, and that will do. So I compile, build, and execute this, and there we go, we get this number printed, and it's printed as minus 95.56 gets printed as minus 95.559998. The reason why it's being printed like this is because this number minus 95.56 is not perfectly represented by the computer under the hood. Okay, for a 4-byte floating point number, this value is not being properly represented. Okay, and don't worry about it, let it be. Okay, we'll find a way to use this, fix this. Okay, now what we can do is there are a few format specifications to here, like little more additions, and the first thing we look at is that the digits before the decimal point. Okay, now if I compile, build, and execute this, there we go. What this says is that it tells the number of significant digits you want to before the decimal point to be represented accurately. Okay, that is the way, that is the notation for that. This is similar to your integer specification. If you want the how many numbers do you want, how many spacings, or what is the character width you want for the number to be present, it's to be printed out, and this is similar to that. Okay, and now likewise there is another option over here, and this is more important than this one. With this option over here, if you put a dot and a number and then before the f, okay, you can specify how many digits you want the number to be represented after the decimal point. So let's show you. Here we go. The number is 95.56, but if you represent it with in free formatting, it will be represented as 95.55998, like that. Okay, but if you just round it off to 3 digits, let's say, three digits, let's say, it gets printed printed nicely, 95.560. What this number says is that it tells how many digits you have to should I print, or how many digits should I print after the decimal point. And if the number is much longer, let's say has more digits, then this will truncate. If the number has more digits, let's say, then the number will be approximated, rounded up or rounded down to print accordingly. And now there is this extended feature over here. Okay, this is like the combination of both. So if I compile, build, and execute this, okay, this will include the combination of both. It'll allocate four spaces for the number before the decimal point, and 3 spaces for the part of the number after the decimal point. If suppose this format specification is not sufficient and the number is sufficiently long, especially in the front before the decimal point, then this by default the manual specification will be overruled and the default specification will be taken into consideration. Okay, and you might ask me, is there any padded zeros option? Well, let's check it out. apparently the padded zeros, I mean if you want to add zeros to the front of the number, this option is not there in floats. And similarly there's one more option over here which is actually called as the long float. So if you are working with doubles, let's say, you can either put G or you can also put LF, which is also available. And LF in specific is actually the long float free format specification. Okay, this will work out fine. Although you may not see a difference, but if you have a double and you want to print it out, you can use LF and it will work. So just let's try this out. Let's say I put this as double, let it be, and I compile, build and execute this. Yeah, perfect, it's coming out well. Okay, and let it be float as for now. Okay, and now do I have any format specifications for long float? Yes, I do. I think instead of here I just put double so that this long float will come out very well. And if I compile, build and execute this, well, you see now the format specification works. So what are the different specifications? Nothing similar, nothing much. It's exactly the same specification that which were applicable for F. They're also applicable for LF. So you can just reuse the exact thing. So without any consideration. And then there is this G. Okay, this format specification is applicable for double, long float as well as just plain floats. Okay, and here is actually here will be a difference, a big difference. If I compile, build and execute this, check this out. The number gets printed as it is. Now just for comparison, I'm going to keep %f and %g, and I'm going to print the numbers. Okay, print the same number in two different formats, and check this out. Clearly, when I use %f, the approximations, whichever the number which was not represented properly by the computer under the hood, gets represented in its approximated form. Whereas when I use %g, the number gets represented exactly. Okay, so this is the inference over here. If you come across numbers that you cannot represent properly, use %g, and that will make sure it will be represented accordingly. What %g says is that while printing the number, while printing the floating point numbers, the numbers will be converted into the equivalent double value, and then that double value will be printed over here. So the actual number, which is minus 95.56, which was 4-byte float, okay, gets converted into a double, and that double will be printed as it is, will be printed over here. So thereby retaining more precision than the initial specification. So wherever if you come across specific precision issues, or wherever you need more precision for the floating values, use %g over %f, and they will work the same. And similarly, just like all the format specifications that we looked at for f and long f, I mean float and long float, the same hold good for %g. So you can use them as it is without any problem. And the next format specification that we look at is %e. Suppose if you want to print the number in a scientific notation, okay, like some value times 10 power something like that, like 3 times 10 power 8 or something like that. Okay, this format specification is very useful. Let's have a look. So if I compile, build and execute this, and there we go. This number 95.56, this is how it is minus 95.96, this is how it's represented. So if you were to write this, I can write this as 9.556 times 10 power 1. Okay, that is what is written over here. So just to avoid confusion from 10 over here, Okay, in the computers they use e instead of 10 to represent it. By default, if it's e plus, if it's like this, that means that this is like, this number is minus 9.556 into 10 power 1. Okay, and so let's suppose if I have value like 0.9556. okay, now if I compile, build and execute this, okay, this is, if I were to write this in scientific notation, I'll write this as minus 9.556 10 power minus 1, and that is what is written over here. Okay, this minus indicates the power to which this is sign of the exponent of the exponent, and exponent here, and here the exponent is not the e, but it's actually 10, not the transcendental number e 2.7182, not that, it's just 10. Okay, and this is actually the actual mantis. Okay, that's how it works. So I think now you get it. 95.56. And now sometimes people might prefer the exponent value with such that the e is capitalized. So for that you need to use percentage e over here. This will make sure that in the scientific notation you have uppercase e instead of a lowercase e. So if I execute this is how it is. Previously it was just a small lowercase e. So let me put this, both of them in comparison. So previously, just if you look at it, the number is printed with the percentage e, with e with a small letter. Now it's printed with a bigger letter. Okay, and that's the difference. And also you have the option to put some format specifications. And here the format specifications look similar to the float. Okay, the only thing being is that instead of you just have only the control of the digits after the decimal point. So okay, you can just control the number of digits after the decimal point, because these two are always there. Okay, a place for the sign and a place to put the first digit, that is always there in scientific notation. The only thing that is under our control is the number of digits that you like to choose to print after the decimal point. So you have a control over that. So if you put a dot 4 over here, it means that you print up to 4 decimal places after the dot. So if the number is much longer than that, it will be truncated. It will be truncated. It will be rounded up or approximated accordingly before being printed over there. So that way you have an option to control the way the numbers have been printed and being read through. Okay, so with this, that's all I have for you guys in this video. This is a full exhaustive explanation of all the format specifications for the floating point values. Okay, and when we come across strings in the future, I'll explain about the format specifications for character. But the format specifications for character are pretty simple. You just use %c to print the character as it is, %d get the numerical equivalent of it, and that's about it. Okay, with that being said, that's all I have for you all in this video. Thank you all for watching, and in the next video we look at some other interesting topic. Until then, take care.